Namaskaram everyone. Good morning and welcome back for mathematics webinar for junior inter students. You've been learning about straight lines from mathematics 1B. We've already completed the various forms of straight lines, and Madam Saishwari, principal of TSMS Munagala, Suryapet district, has already started straight lines 4 sessions ago. And in the 4 sessions, we have covered various topics, starting from slope till the angle between the lines, perpendicular lines, parallel lines. Then how do we find out whether the lines are intersecting or not? All the concepts in detail were explained, and you were given some assignments also for you to practice. Hope students, you must have already completed working out all those exercise problems Madam has asked you to do. And today, one important problem, like it may be asked for 7 marks in your examination. So the concept related to concurrency of altitudes, medians, and perpendicular bisectors and bisectors of internal angles. All these concepts are going to be dealt by ma'am. Madam, I'm really honored to actually be a part of the same team wherein you are taking up the lesson, and you are an inspiration to many of us. With the kind of administrative responsibilities that we are holding, the amount of effort that you put in and the dedication that you have towards preparing the lesson and presenting it to the students is amazing. I'm struck by the magnificent effort that you put in, ma'am. And without wasting much of your time, students, I take this privilege welcoming Mrs. Saishwari, Principal of TSMS Munagala. Madam, over to you.
Thank you, ma'am. Thank you so much. I'm blessed. It's a great opportunity for me to meet all these students throughout the state through this YouTube channel, and meeting all these students over the 192 model schools of Telangana is a great privilege to me. Thank you for the great opportunity given by my maths team. And good morning, students. Let us move on to the straight lines, lesson 5. I hope you must have gone through lesson 1, 2, 3, 4. Straight lines is really a magnificent chapter where it goes beyond the sky. Even if I take up another 3 to 4 sessions also, it wouldn't be enough for me. But then, not to get you people bored, let me concentrate on the most important part of your examination. Today, the entire lesson, each and every slide is most important for you in view of your public examination as well as your competitive exams and for your future courses also. Whether you're going for an engineering course or for a degree course, wherever you go, these straight lines would follow you. So be alert. Shall we start? Get set. Here we go. Right. So we have seen in the last part the image, the foot of the perpendicular of a straight line. Hope you remember that. And a tribute to the PSLV that has gone into sky yesterday. So what are we going to learn today? Today, we are going to recapitulate lesson 4, which is very, very important, and revise the foot of the perpendicular formula. Then extend this to the image of a point and find circumcenter, orthocenter, and incenter. So here, you're going to put 7 plus 4, nearly about 11 marks into your pocket, dear children. So I hope you know the passing marks are just 26 to 27, 1B 27 probably. So out of 27 marks, today only this particular video will give you 11 marks into your pocket. So, okay, let's not stress about the marks. Let's go ahead with the subject. Yeah. So let's recapitulate the angle between two lines. The angle between the straight lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 is given by cos theta is equal to a1 a2 plus b1 b2 by root of a1 square plus b1 square into root of a2 square plus b2 square. Next, we have seen the equation of the straight line. Perpendicular to the straight line ax plus by plus c equal to 0 is of the form bx minus ay plus ay is equal to k. Please do remember this form. We will be using this form in our coming slides. A line perpendicular to ax plus by plus c is going to be of the form bx minus ay equal to k. Similarly, the equation of any straight line parallel to the straight line ax plus by plus c equal to 0 is in the form ax plus by equal to k. Now, we have also seen the length of the perpendicular from a point to a line. The length of the perpendicular from the point P of x naught y naught to the straight line ax plus by plus c equal to 0 is modulus of ax naught plus by naught plus c by root of a square plus b square. We've also seen the distance between two parallel lines. The distance between two parallel lines ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 is given by modulus c1 minus c2 by root of a square plus b square. So you can see in the diagram, this length pm is what we are talking about, the distance between two parallel lines. Now, the foot of the perpendicular was the last thing that we have discussed in lesson 4. I hope you remember. The foot of the perpendicular, if q of h comma k is the foot of the perpendicular from the point P of x1, y1 on the straight line ax plus by plus c equal to 0, then this h comma k can be found using this formula h minus x1 by a is equal to k minus y1 by b is equal to minus ax1 plus by1 plus c by a square plus b square. Now let us extend this particular formula to find what is called the image of a point. I hope you all know what is an image. Image is nothing but what we see every day in our mirror. Is it not? Yes, in physics you have learned more about images in concave mirrors, convex mirrors, etc., etc. Now here we are going to see how to get the image of a point x1, y1 with respect to a straight line ax plus by plus c equal to 0. This is how we get it. The formula is h minus x1 by a is equal to k minus y1 by b is equal to minus 2 times ax1 plus by1 plus c by a square plus b square. This is very similar to the foot of the perpendicular. I've scrolled down to the previous slide to just tell you what is the difference between foot of the perpendicular and the image. Both are almost the same except for the minus 2 twice this one. Because as you know, the distance from the point to the line is 1 unit, and again from the point to the image is another unit. So suppose there is a line L here, and you have a point called P of x1, y1 here. Now the distance from this point to L, this is foot of the perpendicular. Is it not? Now again from this point to another point, that is, which is equidistant from the line, that is called the image. And so that is why we get twice the length here. Now, how do we get this? Let us take q of h comma k as the image of the point P of x1 by 1 with respect to the line L ax plus by plus c equal to 0. Now here, r is going to be the foot of the perpendicular, which is x1 plus h by 2, comma y1 plus k by 2, which lies on the line L. Now, if it lies on the line L, it should satisfy the equation. Is it not? So that's going to the foot of the perpendicular. So we are going to substitute this x1 plus h by 2 and y1 plus k by 2 in the foot of the perpendicular formula and try to simplify this. Take an LCM 2 and carry here. Similarly, here also take an LCM 2 and carry over here. And you will get the formula for finding the image of the point x1, y1 with respect to the line ax plus by plus c equal to 0, which is nothing but, I repeat once again, h minus x1 by a is equal to k minus y1 by b is equal to minus 2 times ax1 plus by1 plus c by a square plus b square. We ought to remember this formula because many number of times this question was asked, and here we go with the application. So how do you find the image using this particular formula? There's an example here. Find the image of 1 comma minus 2 with respect to the straight line 2x minus 3y plus 5 equal to 0. Now the point 1 comma minus 2 becomes x1, y1. And we have, of course, have to find the image h comma k with respect to the line 2x minus 3y plus 5 equal to 0. Now if you compare this with the standard form ax plus by plus c, you will get a as 2, b equal to minus 3, and c equal to 5. Now let us substitute these values in the formula that we have just learned. H minus x1 by a is equal to k minus y1 by b is equal to minus 2 into ax1 plus by1 plus c by a square plus b square. Here, this line shows us the simple substitution of x1, y1, and also the a, b, c here. So on simplifying this, you can see that this becomes h1 minus 1 by 2, and minus or minus becomes plus. So this becomes k plus 2 by minus 3. And here this becomes minus 2 into 2 ones are 2, minus 3 into minus 2 becomes plus 6, plus 5 by 2 square is 4, and minus 3 square is 9. So here this is 6 plus 2, 8, 8 plus 5, 13, 13 twos are 26. That is how we get minus 26 by 13. Obviously, you understand that it is minus 2. Now, let us take each of the parts. So, previously, what was the last line that we have seen? We have seen this is the last line. So, here, each individual ratio must be equated to this minus 2. So, in the next step, we are going to take h minus 1 by 2 is equal to minus 2, from which you can take 2 to the other side. 2 of the denominator on the LHS can be taken to RHS, becomes 2 2s are minus 4 here. Now we can also take the minus 1 to the other side, becomes plus 1. So H is minus 4 plus 1 equal to minus 3. Now similarly, as we got H equal to minus 3, we can also similarly calculate the value of K. K plus 2 by minus 3 is minus 2. And so k plus 2, if you take minus 3 to the right side, you will get minus 3 into minus 2 as 6. And plus 2 goes to the right side, becomes minus 2. And so k becomes 4. So here, the image is minus 3, comma 4. Hence, the image of the point 1, comma minus 2 with respect to the straight line 2x minus 3y plus 5 equal to 0 is h comma k is equal to minus 3 comma 4. Now let us learn some properties related to concurrence. There are various geometric proofs for concurrency, like concurrency of medians of a triangle, concurrence of altitudes of a triangle, concurrence of internal bisectors of the angles of the triangle, concurrence of the perpendicular bisectors of sides of a triangle. Now, all these definitions, one or two you must have learned in your 10th class, and one or two you must have learned in your chapter called locus. Now, here we go with more detailing about what do we mean by concurrency of medians. Now, I hope you remember what is a median. This is the definition somewhere in your middle school you must have learned. Median, as the name suggests, it is the line joining a line drawn joining the vertex of a triangle and the midpoint of its opposite side. So suppose I have a triangle ABC like this. Now take the midpoint of BC and suppose it is denoted by D. Now if you join A and D, this particular line is called the median. Now the point of concurrence of medians of a triangle is called centroid. Now I can draw medians to all these sides, is it not? I can have another median which is starting from B, another median which is starting from C. So all these medians will definitely meet at one point or they intersect each other at a point, and that point is called centroid. And usually this centroid is denoted by the letter G. So the medians of a triangle are concurrent. Is it not? So if you draw all the medians in a triangle, you take a triangle like this, draw a median AD to BC. Similarly, draw BE to AC and also CF to AB. All these will definitely meet at a point, and that point is called the centroid of the triangle. Now, the centroid formula you must have learned in your previous class, which is x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. It is as simple as simply adding all the x coordinates and dividing it by 3, and also adding all the y coordinates and dividing by 3. The detailed proof you have learned in your 10th class. Now here, the next thing is concurrence of altitudes of a triangle. Now what is an altitude? Altitude is nothing but the height, a very common word you have been hearing since your schooling. Now, if I draw a perpendicular from a vertex to the opposite side, sometimes it may go beyond the triangle also, especially when you talk about obtuse angle triangles. Height may not lie inside the triangle, it will definitely go outside the triangle. So it is simply a perpendicular drawn from one vertex to its opposite side. That is called an altitude. The perpendicular drawn from a vertex to its opposite side is called altitude or height. Now, I can draw all three heights from all three different vertices. Is it not? An altitude from A dropped from A, another altitude dropped from B, now another altitude dropped from C. Now, these are perpendiculars, means which are making angle 90 degrees with their opposite sides. And as you can see in the diagram, these also meet at a point or they intersect each other at a point called the orthocenter. Remember, children, wherever you get this word ortho, please remember in mathematics, ortho means perpendicular or something which is straight to other line. Say an orthopedician. Who's an orthopedician? An orthopedician is one who straightens your broken bones. Is it not? It is straightening. So here also, orthocenter is the concurrence of the altitudes of a triangle. And altitudes are nothing but the heights or the perpendiculars dropped from each of the vertex to its opposite side. Now here you can see that these altitudes are concurrent and they all meet at a point called the orthocenter. So the altitudes of a triangle are concurrent. Actually, we have a very elaborate proof to prove that these altitudes are concurrent. I just want to skip this part because you will read this part again in vector algebra and you will prove using vector method that these altitudes of a triangle are concurrent, the angular bisectors are concurrent, and so on. So I'm just leaving out the proofs here in coordinate geometry because you'll concentrate them more in your vector algebra. Now here the concurrence of the internal bisectors of the angles of the triangle. Internal bisectors of angles. The name itself suggests that it is going to be internal, that is inside the triangle. Bisector, bi means what? Two. It is going to divide a particular angle into two equal parts. Bisector. Bi means two. Sector means equal parts. So this line, which is dividing or cutting a particular angle into two equal parts, is called the internal angular bisector. So the internal bisectors of the angles, what are they? They are just the line drawn from vertex of a triangle such that it divides that angle into two equal parts internally, and these are called internal bisectors of the angles. Now when you say internal angular bisectors, obviously you must be getting a doubt. Do we have external bisectors also? Yes, we do have external bisectors of the angles of the triangle, which you will learn in a topic called properties of triangle in trigonometry. So there's a topic called trigonometry in your mathematics 1A this year itself. And that particular topic, you will know the external angular bisectors. Now, these internal angular bisectors, I can have to for all the three angles of a triangle. So, if I can draw a bisector for angle A, I can also draw a bisector for angle B, similarly to angle C. Now, again, you can see that all these internal angular bisectors intersect with each other and they meet at a point which is concurrent, and that point is called the incenter. It is called the incenter. So the point of concurrence of internal angular bisectors of the angles of the triangle is called the incenter. So what is incenter? Incenter is just the point of concurrence of all the internal angular bisectors. Now, how to find this incenter? Now, there's a formula which states like this. It is ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. Now, incenter is always denoted by I. Centroid is always denoted by G. Okay. Orthocenter is always denoted by O. Incenter is denoted by I. Now, how do we get I? This is the formula. Now, here in this formula, A, B, C, the small a, B, C, stand for the lengths of these sides. Small a is the length of the side BC. Small b is the length of this side opposite to angle B, which is CA. And small c is length of the side AB, which is opposite to angle C. Now, if you just simply find the lengths, once the vertices are given, you will be able to find the incenter. Now, here we are going to see the concurrence of internal bisectors of angle. And as just now we discussed, the internal bisectors of the angles of a triangle are also concurrent. And definitely you will do this proof in your vector algebra. Now, we also have the perpendicular bisectors of the sides. Previously, we have seen angular bisectors. Now, here we are going to see the bisectors of these sides. Wherever it is bisector. Bi means two. Sector means parts. So, bisector means it is going to divide into parts. What is going to divide into parts? The perpendicular to a line is going to divide the side into two equal parts. Now here you can see there is a line drawn from A to D, which is both perpendicular and it is bisecting the side BC. Now when I say it is bisecting the side BC, obviously we understand that D is the midpoint of BC. And if you remember from your 10th class formula, the midpoint formula. Now B is x2, y2 and C is x3, y3. And so the midpoint is x2 plus x3 by 2, y2 plus y3 by 2. So here we have the definition, perpendicular bisector of the sides. These are lines drawn from a vertex to its opposite side, which intersect at midpoint and also are perpendicular to the side. So they're bisecting and are perpendicular. There are two things happening here with the side. So like this, how many perpendicular bisectors can we draw? Obviously, again, 3. Now for each of the sides, from each other vertex, we can draw 3 perpendicular bisectors. And to our surprise, all these are concurrent again. So the point of concurrence of all these perpendicular bisectors is called the circumcenter, which is denoted by the letter S. So what is circumcenter? The point of concurrence of perpendicular bisectors of the sides of a triangle is called circumcenter, which is denoted by the letter S. And do you have a doubt that will they be concurrent? Yes, there is a theorem which tells us that the perpendicular bisectors of the sides of a triangle are concurrent, and the proof goes beyond our video today. And so please learn them in vector algebra. Now let me focus more on the problems. So what are all the centers that we have seen? We have seen angular bisectors, which is in center, bisectors of these sides, which is circumcenter, the concurrence of altitudes, which is orthocenter, and the concurrence of perpendicular bisectors, which is circumcenter S. So let us go into the problems so that you will be able to see how actually we can calculate each of the things. Now here the data may be of two types. Either directly you will be given the vertices, or you will be given the equations of the sides of the triangle and you will be asked to find. Now here the first example is, find the incenter of the triangle formed by the vertices 1, root 3, 2, 0 and 0, 0. Now, as I have told you before, to find the incenter I, we use the formula ax1 plus bx2 plus cx3 by a plus b plus c, ay1 plus by2 plus cy3 by a plus b plus c. And here, a, b, c are the vertices of the triangle which are given from the hypothesis. And I is going to be the incenter, which is the angular bisector. Now, the first thing that we have to find is we have to find the small a, b, c, which are the lengths of these sides. Now, a here, as I have told you previously, a here stands for the length of the side BC. So, I'm here using the distance formula. I hope you remember the distance formula, root of x2 minus x1 whole square plus y2 minus y1 whole square. I've just applied the distance formula and found the distance between BC, which is root of 2 minus 0 whole square plus 0 minus 0 whole square, which is 2. Similarly, I have found the B, small b, which is the length of the side AC. So A here is 1, root 3 and C here is 0, 0. So the distance between those two things is 1 minus 0 whole square plus root 3 minus 0 whole square. So 1 minus 0 whole square becomes 1 and root 3 minus 0 becomes root 3 whole square, where the root and the square get cancelled. So here we have 1, here we have 3. So 1 plus 3 becomes 4 and root 4 becomes 2. Next, let us find C, which is the length of the side AB. Now here A is 1, root 3 and B is 2, 0. Applying distance formula, we have 2 minus 1 whole square plus 0 minus root 3 whole square. 2 minus 1 whole square is 1 square, which is 1. Root 3 minus 0 whole square is root 3 square, which is 3. So 1 plus 3 again is 4 and root 4 is 2. Here to our surprise, all the three sides are equal. If all the three sides are equal, what kind of triangle it is? Yes, if all the three sides are equal, it is nothing but an equilateral triangle. Now, in this equilateral triangle, how do we get the incenter? So here we have got ax1, y1 as 1, comma root 3, bx2, y2 as 2, comma 0, cx3, y3 as 0, comma 0. Now we have found the values of a, b, c, which are all equal to 2, 2, 2. Now let us substitute all these values in this formula. So ax1, a is 2, x1 is 1, so 2 into 1, bx2, 2 into 2, cx3, 2 into 0, by a plus b plus c, 2 plus 2 plus 2. Again, a y1, 2 into root 3, b y2, 2 into 0, c y3, 2 into 0, by a plus b plus c, which is 2 plus 2 plus 2. And on simplifying this, 2 ones are 2 plus 4, 6 plus 0 is 6 by 6. And here this is 2 root 3 by 6. Now on cancellation, we get the incenter I as 1 comma root 3 by 3. Now this 3 in the denominator can be written as root 3 into root 3. And on cancelling 1 root 3, we get the incenter I as 1 comma 1 by root 3. This is how we can find the incenter. Incenter is I equal to ax1 plus bx2 plus cx3 by a plus b plus c, comma ay1 plus by2 plus cy3 by a plus b plus c. Now here next we move on to finding the orthocenter of a triangle whose vertices are minus 5, minus 7, 13, comma 2 and minus 5, comma 6. Orthocenter, as you have to recall from the definition, ortho means straight or perpendicular. So these are the point of concurrence of the perpendiculars drawn from the vertices. Is it not? So we have to find the perpendicular here. So what is perpendicular to what? AD is going to be perpendicular to BC. Now here we have got all the vertices. So we have got the point A, and we have got the points on the line BC. So first let us try to find out the slope of BC. Okay, so here we are going to take two altitudes, namely AD, perpendicular to BC, which is drawn from A, BE, be the perpendicular from B to AC. So our story starts with finding the slope of BC. Slope of BC, B is 13, comma 2 and C is minus 5, comma 6. Now, hope you remember the slope formula, y2 minus y1 by x2 minus x1. And on substitution in it, 6 minus 2 by minus 5 minus 13 gives us 4 by minus 18, which is minus 2 by 9. This is the slope of BC. Now, if you remember in the first lesson, we have learned that the product of perpendicular slopes will give us minus 1. Here AD is perpendicular to BC. And so what will be the slope of AD? It will be the negative reciprocal of BC, minus 1 by M. So minus 1 by minus 2 by 9, which is 9 by 2. That is the slope of AD. Now here I have to find the equation of AD. So what are the things I have? I have the point A, minus 5, minus 7, and the slope of the line AD, which is 9 by 2. So if we know the point and the slope, you can recall from lesson 2 the different forms that we have learned. The point slope form will be of more use to us, which is y minus y1 is equal to m into x minus x1. Here on substitution of minus 5, minus 7 in the place of x1, y1, and in the place of m, we are going to take 9 by 2. We get y plus 7 is equal to 9 by 2 into x plus 5. Take the 2 to the other side. 2 into y plus 7 is equal to 9 into x plus 5. Open up the brackets. 2y plus 14 is equal to 9x plus 45. So 2x, so bringing all the constants to one side, we get 9x minus 2y is equal to minus 31. And let's call it as equation 1. Now, what is the equation of AC? As you can see there, the both x coordinates are same. So the equation of AC is going to be x is equal to minus 5. And therefore, x is equal to k is a line parallel to y-axis, and so AC is going to be a vertical line. Similarly, if AC is a vertical line, obviously a line perpendicular to that will be a horizontal line. Is it not? Because x is perpendicular to y. And so a vertical line will be perpendicular to horizontal line. And so what is its equation? It is nothing but y is equal to 2 because it is passing through 13, 2. So this is the equation of B. Now we have to find the point of intersection of y equal to 2 and 9x minus 2y equal to minus 31. Now here it is only a simple substitution of y equal to 2 on this. You will get 9x minus 2, 2s are 4 is equal to minus 31, or 9x is equal to minus 31 plus 4. Using that process, you will get the value of x as minus 3 and the value of y as 2. Hence, minus 3, 2 is called the orthocenter of triangle ABC. Now, next, let us move on to the next problem. If the equations of the sides of a triangle are 7x plus y minus 10 equal to 0, x minus 2y plus y equal to 0, and x plus y plus 2 equal to 0, find the orthocenter of the triangle. What is the difference between the previous problem and this problem? There also we had to find orthocenter. Here also we have to find orthocenter. Now then what is the difference? The only difference is there the vertices of the triangle were given. Here the equations of the sides of the triangle are given. Now the equations of the sides are given. Each one we have to take them as AB, BC and AC. Then our work is little bit easy. How? Suppose I have a line x minus 2y plus 5 equal to 0. Now what is a line perpendicular to that? If you remember, we have discussed a line perpendicular to ax plus by plus c equal to 0 is going to be of the form bx minus ay plus c plus k equal to 0. Now here there are two ways to do. Either you have to find the vertices. How do you find the vertices? Try to solve 1 and 2. You will get the vertex B. Solve 2 and 3. You will get the vertex C. Solve 1 and 3. You will get vertex A. So solving each of the points here, you will get the vertices. And using the vertices, again we go with the same process that we have discussed before. So once you get the vertex minus 3, 1, again we go with the concept of AD perpendicular to BC. Now what is the equation of AD? It is x minus 7y is equal to k. And in the place of k, I can simply substitute the vertex and get the value of the constant as minus 10. So how did I get this? This is the concept that we have learned in our previous lesson. That is the equation of the straight line perpendicular to the straight line ax plus by plus c equal to 0 is of the form bx minus ay equal to k. So here a line perpendicular to 7x plus y minus 10 will be of the form x minus 7y. That is the coefficients of x and y get interchanged and you get a constant which is something different from minus 10. And here also, surprisingly, the constant is minus 10. Now again solving equations 1 and 2, you get the vertex B. Now again B is perpendicular to AC. Now AC equation is x minus y. The equation of AC here is x plus y plus 2 equal to 0. So any line perpendicular to this x plus y plus 2 equal to 0 will be of the form x minus y equal to k. Now how to find k? Simply substitute this point 1, 3 in that. So 1 minus 3, which is minus 2. So that's how you get the constant. Simply substitute this point in this equation. So what is the equation of B? It is x minus y equal to minus 2. Now simply solve the equations of AD and B. You can either use the elimination process that you have learned in your 10th class or the point of intersection formula which you have learned in straight lines. Either of it, it is finally to get the point of intersection which is minus 2 by 3, 4 by 3 and that is called the orthocenter. So if the sides of the triangle are given, We have to solve two equations at a time and get the vertices. Then go with the process of orthocenter. Ortho, again, I remind you, ortho is perpendicular. Now here we come with the most important section, that is finding the circumcenter of the triangle. Now again here we have two ways. What happens if the vertices are given? What happens if the sides are given? So let us try to find the circumcenter of the triangle whose vertices are 1, 3, minus 3, 5 and 5, minus 1. Here let us discuss. There are two methods to do this. One is a regular IPE method where you can derive elaborately. And there is another method which also you can use in IPE, but it will be of more easy way for you to use in your competitive exams. That's a shortcut actually. So here let us look into method 1, the elaborate way of doing this. So we are given a triangle with vertices A1, 3, B3, 5 and C5, minus 1. Now first thing here is to find the midpoint of BC using the formula x1 plus y1 by 2, sorry, x1 plus x2 by 2, y1 plus y2 by 2. So also find the midpoint of AC using the same formula. So here, let us take the vertices, the given three vertices as A, B, C, A 1, 3, B minus 3, 5, and C 5, minus 1, and find the midpoints of BC and CA using the midpoint formula. Now, after this, what are we going to do? Let us take S as the point of intersection of the perpendicular bisectors of the sides BC and CA. Now here we have to again calculate the slope of BC because we want a line perpendicular to it. So what is the slope of BC? Again, it is y2 minus y1 by x2 minus x1. You can see this is 5 minus of minus 1 plus 1 by minus 3 minus 5. 5 plus 1 is 6, minus 3 minus 5 is minus 8. Cancelling by 2, you get minus 3, 4. Similarly, the slope of SD. Slope of SD is going to be what? It is minus 1 by slope of BC because SD is perpendicular to BC. So here SD is perpendicular to BC. So product of slopes is going to be minus 1. And so we get the slope of SD as 4 by 3. Now I know the slope and I know the point D, which is the midpoint 1, 2. So using point slope form and substituting the point as 1, 2 and the slope of 4, 3, we get y minus 2 is equal to 4 by 3 into x minus 1. Taking 3 to the other side, 3 into y minus 2 is equal to 4 into x minus 1. Or 3y minus 6 is equal to 4x minus 4. On simplifying it, we get 4x minus 3y is equal to minus 2. Now, use the same process to find the slope of the, equation of the other line. So, we will be using the same process again to find the slope of AC because BC will be perpendicular, B will be perpendicular to AC. So B will be perpendicular to AC. So again, we take the slope of AC here. Calculating the slope of AC using the same formula y2 minus y1 by x2 minus x1, we get 3 plus 1 by 1 minus 5, which is minus 1. And so the slope of AC is going to be 1. Again, we know the point E, 3, 1 and the slope 1. Using point slope form, we can find the equation as x minus y is equal to 2. Now simply solve the equations of AD and B. It is only point of concurrence of these two things or the point of intersection of these two things. So either use elimination process or the point of intersection formula and you will get the circumcenter of triangle ABC, which is S as minus 8, minus 10. Now let us see the same problem in another method. What is this method? Here, let us use one more concept. The concept is geometrically the circumcenter will be equidistant from all the vertices. Because in properties of triangles, you will be learning that there will be actually a circle which you can draw with this circumcenter as center. And if a circle is drawn, that will definitely will pass through all these vertices of the triangle. So which means this SA, SB and SC would become the radii of the circle. And so as you know, the radii are always equal wherever you take on the, whatever points you take on the circle. Here, I'm going to use that concept of SA is equal to SB equal to SC. So here in the problem, whatever vertices are given, let us take them as 1, 3, minus 3, 5, and 5, minus 1. And I have said there will be a circle drawn. If you draw a circle with circumcenter as center and SA as radius, that circle will pass through all the three vertices, and hence all the radii SA, SB, SC would be equal. Now if I use this concept and solve, how do I solve? SA is going to be the distance between S and A. So we will use distance formula. X2 minus x1 whole square plus y2 minus y1 whole square, and find the distance SA. Similarly, find the distance SB using the same formula, and also find the distance SC using the same formula. Now here S, we are going to assume it as x comma y. Now if you remember, in locus, you must have done a lot of problems where you will assume the locus as x comma y and get the equation of the locus. Here also we are going to use the concept of locus, assuming S as x comma y and equating SA is equal to SB first. Okay. Out of SA equal to SB equal to SC, the first part we are going to take is SA equal to SB. So both the distances are equal. Now let me simplify that. X minus 1 whole square is x square minus 2x plus 1. Y minus 3 whole square is y square minus 6y plus 9. And x minus half minus plus 3 whole square is x square plus 6x plus 9. And y minus 5 whole square is y square minus 10y plus 25. Now, if I squaring on both sides, by doing squaring on both sides, the roots are eliminated. And when roots are eliminated, you can cancel the terms x square, y square on both the sides. You will get only the linear factors and constants. And on simplifying them, you will get the equation as 2x minus y plus 6 equal to 0. Now, let us repeat the same process by taking S, A, B, C. And this time we are going to take SA is equal to SC. Now, if you take SA equal to SC and repeat the whole process with this, what is going to happen? Again, both the distances are equal. Now, simplifying under the root, expanding using A plus B whole square formula. Again, squaring on both sides, the roots are lost. And on simplifying, x squared and y square are lost. We are landing up with a linear factor and a constant. And taking all the terms to one side and simplifying it, we get an equation called x minus y minus 1. So now we are going to solve these equations. 2x minus y plus 6 equal to 0 and x minus y minus 2 equal to 0. Now, if you solve these two equations, I have used the point of intersection concept. I hope you remember this is one concept we have learned in straight lines. The point of intersection process using cross multiplication method. You only have to take the coefficients of y constant, then x, again constant, and again y. So here the coefficient of y is minus 1, then comes 6, then comes x coefficient, and again repeat the y coefficient. Do the same thing to the second equation. So here this is minus 1, minus 2, 1, and minus 1 repeated again. Now take the cross product. Okay. And apply the formula, finding the point of intersection B1C2 minus B2C1 by A1B2 minus A2B1. C1A2 minus C2A1, A1B2 minus A2B1. Okay, if you don't want to do this, you can simply solve this. See, if you suppose you subtract these two equations, y will be lost. 2x minus x will give you x. 6 plus 2 will give you 8. So x plus 8 equal to 0 or x equal to minus 8. Simple way you can get. Or you can substitute in the point of intersection formula and you can get the circumcenter s as minus 8 minus 10, which is the same as the equations that you have derived. So what are the two methods? The circumcenter, you can take the vertices, find the midpoints, find the equations of perpendicular bisectors AD and BE and solve them. Or otherwise, you can go with the locus concept, SA equal to SB equal to SC, in which you have to take SA equal to SB, then SA equal to SC. You will get two equations and solve those two equations to get the point of intersection. So this would be a shorter method for you actually for your competitive exams. That's actually a shortcut. Now here we have the circumcenter to be found when the sites are given. If the sites are given, what is that we have to do? Now if the sites are given, you take them as the sides BC, CA, AB respectively. Now take two of the equations at a time and try to solve them. Now solving process, you have lots of choices. Whatever way you find easy, you can do it. So each time you take two equations, there are three equations here, is it not? Take two at a time and solve. You'll be getting each of the vertices there. Now, once you get the vertices, you have again choice of two methods that just now we have discussed. Either you can find the perpendicular bisectors, that is AD and BE, and find the point of intersection of these two equations, or else you can use the method of SA equal to SP equal to SC. So whichever method you feel like easy, you can do it to get the circumcenter of triangle ABC. And with these concepts, you have exercise 3 in page number 74, 75, 76 in your textbook. Children, please do practice these problems. Each of the problems are discussed elaborately in this video. Watch the video again and again so that you can solve these problems. And these problems are a must in your public exam. Okay. Thank you so much for listening, for viewing so patiently. And from my bottom of my heart, I thank our additional director, sir, who has given a wonderful chance to all the students of the model school to have been watching this, not to lose any contact with the college, though we are virtually distant. And I also thank Sridevi madam for her lot of patience, because I was calling her in the odd hours. We were doing trial runs at the late nights, especially nearly 2 and 3 at a time. So thank you so much, madam, for all the patience you have and the commitment and strength that you have. God bless you, ma'am. This will help a lot of students across the state, and coordinating all people like me, especially who don't lift a phone over 2 to 3 rings. So you have been really patient enough with me and cooperated with me. So thank you very much, ma'am. Thank you so much. I'll remember this for a lifetime. Thank you. Over to Sridevi, ma'am.
Thank you, Saishwari madam. That was such a wonderful session, and I learned many things from you. It was a pleasure. It was a pleasure being associated with you, and we will cherish it. And thank you for taking the students on a tour of straight lines for 5 continuous sessions. Students, see, it is not praising each other. We want you to take certain, actually learning from this, that in spite of having such an hectic schedule and so many responsibilities, being principals, madam has taken tremendous effort and then brought in so many concepts and various methods in order to teach you straight lines. Hope, and I'm sure you will definitely follow all the instructions given by madam Revisit the same lessons on the YouTube channel and make a note of all the important points as well. You please use the textbook and solve all the questions that Madam has given. Madam, it was really a pleasure to have you in the team of mathematics. I have learned many things from you, and it is like very small if I put it in a simple word as thank you. Thank you so much. Thank you, students. We'll meet again with another other interesting session.
Good luck, all of you. All the best.